Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. We will do something unusual today. We will do the same problem as yesterday. This is the same problem as the May 16, 2018 problem, but we will do it differently without any significant calculation of any integral, and by using the properties of the exponential distribution and the gamma distribution. And you should know those properties. That's why I want you to have a look at this problem from that perspective. So here's the problem. Auto-claim amounts in thousands are modeled by a random variable with density function f of x equal to x times e to the minus x for x greater than or equal to 0. The company expects to pay 100 claims if there is no deductible. How many claims does the company expect to pay if the company decides to introduce a deductible of 1,000? And here is the key story, the alternative approach. There's one more approach to this problem. It relies on noticing that the distribution given is the gamma distribution obtained by adding two independent, identically distributed exponential random variables with mean 1. The density of an exponential random variable with mean 1 is e to the minus x for x greater than 0. And when you add two of those, independent, identically distributed, you get a gamma distribution whose density is equal to x times e to the minus x for x greater than 0. In general, if you add, let's say, n independent, identically distributed exponential distributions, you get a gamma distribution. I do discuss this in more details in the study manual I wrote for the exam. You should know that for the exam. And how do we discuss the exponential distribution in the manual I wrote? Well, exponential distribution is waiting time until something happens. And it relates to Poisson distribution because Poisson distribution is the probability distribution that counts how many of those things happen in a unit of time. And the same unit of time that you use to measure time in waiting until something happens, because when you're waiting until something happens, you're measuring how long it will take, and there has to be a unit of time used to measure. Well, the number of those events that happen in the unit of time follow Poisson distribution if the waiting time follows the exponential distribution, and vice versa. So consider now the Poisson distribution with mean equal to the hazard rate of that exponential distribution, which is the reciprocal of the mean. The hazard rate of exponential distribution is the reciprocal of the mean, but in this case the mean is 1, so the hazard rate is 1 as well. So again, the exponential distribution represents a waiting time for an event, while the Poisson distribution counts the number of those events in a unit of time. The probability that the sum of two exponential random variables exceeds 1 is the same as the probability that the waiting time until the first event corresponding to the first exponential distribution plus the waiting time until the second event corresponding to the second exponential distribution exceeds 1. And that means that during the time from 0 to 1, the number of events that happened is less than 2. Because you're still waiting for the second event, effectively. You're adding 2 exponential distributions. So the probability sought is the probability that a Poisson random variable with mean equal to 1, which is the hazard rate of exponential times the length of time of the period of time, which is 1 times 1 in this case. But in general, you may have to multiply the parameter by the length of time. That's what you consider in Poisson processes, which are on later actuarial exams. Well, definitely tested a lot by the Casualty Actuarial Society, not so much by the Society of Actuaries. But nevertheless, we're talking about the basic properties of Poisson distribution and the exponential distribution here. So the number of those events, which is the value of the Poisson random variable with mean equal to 1, is either 0 or 1, less than 2. The only non-negative integers less than 2 are 0 or 1. And what is that? Well, it's e to the minus 1 times 1 to the 0 over 0 factorial plus e to the minus 1 times 1 to the first over 1 factorial. So it's e to the minus 1 plus e to the minus 1, which is 2 times e to the minus 1, approximately 0.7358. That's, of course, exactly the same value we obtained in the exercise posted yesterday, but I did some calculation of integrals there, although I used the Darth Vader rule and there was really not much calculation as a result, because one of the main ways you get rid of calculations of integrals on actuarial exams is by knowing the Darth Vader rule, because Darth Vader, of course, is your friend. So this is answer E, again. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.